I begin with the problem we did it before. Okay. So there are total 35 chickens and rabbits. The number of legs is 94, and how many chickens are there? Okay. Now, again, I'm going to show you two different ways to do. Okay, the one is the classical way, we without using equations. Okay, but that's only for the small numbers. Okay, the numbers is relatively small, you can easily figure it out. Okay, so let's try. Okay, first, okay, so here's we write the number of chicken. Okay, and here's the number of rabbits. Okay, and then I have another column, it's the number of legs. Okay. So you assume, all of them are chicken, right? Then 0 rabbits. And then chicken, every chicken, there are 2 legs, so 70. And 70 is, of course, way below the 94. So in order to get 94 legs, you have to decrease the number of chicken, increase the rabbits. Okay, so if one chicken is decreased, right? 35 minus 1, let's use yeah. Hold on. Yes, let me erase it. Okay, so 35 minus 1, then here's 1. Now the net change on the legs will be 2 increase 2, right? Okay, that's just up to you. Then so the difference, you have to increase how many, right? It's 94 minus 70, and it's 24. Okay, you have to get 24 more legs, but every time you will decrease one chicken, right? The number of chicken decreased by 1, you get two legs, right? So you put the dots here, and the 35 minus, because 24 divided by 2 is 12. So you have to have a 70 plus 2 times 12, right? Then you get 94. So that's why I have to minus 12, and this will be 12. Okay, so it'll be 12 rabbits, and and 35 minus 12 will be 23. Yeah, that's the way they recommend. Okay, and without using equations. Still, a little bit, equations like you have to figure out 12, but we don't use any variables. Okay. Okay, so this is this works very well. Now we also trying to use equations to solve the problem. I hope you can understand that we don't know how many chickens we have, right? Right. So the number of chickens denoted by C. Okay. Then the number of the rabbits denoted by R. The total should be 35. Okay. Every chicken contributes the number of legs, 2 legs, so 2 times C. Every rabbit contributes 4 legs, so 4 times R. That'll be 94. Okay. So you have 2 linear equations. Okay. Now, how do you solve this tree? You actually want to find the C. So the idea is to eliminate the number, to eliminate R maybe, right? Because you want to find the C. Okay, C is the number of chicken. So what you're going to do is you multiply the first equation by 4. Okay, so 4C and the 4R And the 35 times 4 is going to be 140, right? Yeah, 140. Then this equation called 1, that's equation called 2. So what I'm going to do is equation 1 minus equation 2. Okay. Equation 1 minus equation 2 is 4c minus 2c equal 2c. 4r minus 4r is 0. So the reason I want to multiply 4 is because I want to do subtraction, the r should be gone. Okay. And the 140 minus 94 is going to be 56. Okay. 56, right? 140 minus 94. So C is a 50, right? Yeah, sorry. No, 46. Sorry, that's all my mistakes. Okay, so it's 140 minus 94. Yeah, 46. Yeah, not 56. So 46 divided by 2 will be 23. Okay, so that is a number. Okay, so we are asking how many chickens, right? So that's a different method we can use, but I hope gradually you know how to use the variables to solve and word problems, okay? But the first method is pretty smart, okay? And it's very clear, you make a table of the data, okay? Great. All right, so let's take a look at the second problem. Yeah, okay, legs, chicken legs will be 46. The number of chicken will be 23. Okay. The second problem. So there are 30 chicken and the rabbits. If the total number of legs is 70, how many rabbits are there? Okay, we can use these two methods to solve the problem. I hope you can do that. Okay, so here, number of chicken, again, number of rabbits, okay, number of legs. Okay. So you should assume there's 30 chicken there, 0 rabbits, right? The number of legs will be 60. 60 is less than 70, right? So the 70 minus 60 is 10. So there are difference, 10 difference. So every time you decrease the number of chickens by 1, then the net change in the legs will be 2, okay? Now you want to get 10 more legs. So that means 10 divided by 2 is going to be 5, right? So here 60 plus 2 times 5 will be 70. So that's why I say 30 minus 5, 0 plus 5. So that's be 25. Okay, so there'll be 25 chicken and 5 rabbits. Okay, so the answer will be clear, right? So there'll be 25 chicken and 5 rabbits. Okay, good, Mark. Now, to solve the problem using equations, you can, first of all, you get the equation, the number of chicken plus number of rabbits will be 30, right? And then every chicken get 2 legs, every rabbit get 4 legs. So you get 70 total, okay? Now this time we want to find the number of rabbits, so we just need to get rid of the C. So you multiply the first equation by 2. Okay, that's equation 1, that's equation 2. So this time I'm going to do subtraction. Equation 2 minus equation 1, 2c minus 2c is gone. 4r minus 2r would be 2r. 70 minus 60 would be 10. Okay, and from here, 10 is going to be 2. I is going to be 2, right? Yeah. Sorry, I was 4. No, 5. Yeah, 10 divided by 2 is 5. So there are 5 rabbits. Yes. Okay, so this is how do we solve the problem using equations. Okay. All right, I'm going to ask you to do the next problem. We hope we can solve this problem using two different ways, okay? All right, so I'm gonna let you to try, okay? But so similar to the rabbit problems, okay? Similar to the rabbit problem, okay? So here with 27 tickets of a value, $2 or $5, okay? So total number of tickets 27, right? And the total value is 59. Okay, you just need to know how many $2 tickets John has, right? So this side, the number of the $2 ticket, okay, this will be the number of a $5 ticket, right? Tickets, right? And then here be total value, right? So the idea is you assume that you have 27 $2 tickets, 0 $5 ticket, then the value will be 54, right? Multiplied by 2. Right? Now the difference, right? 99 minus 54, right? Is going to be 45. Okay, so you have to increase $45. So every time you decrease the number of the ticket, a $2 ticket, okay, the net change will be you lost $2 and plus $5. So the net change will be $3. So 54 plus 3. Okay. So similarly, 27 minus 2, 0 plus 2, and the 54 plus 3 times 2. Okay. Okay. So in order to get 45 more dollars, right? You have to figure it out 45 divided by 3, all right? It's going to be 15, right? So you have the 45 here, 3 times 15, then you get a 99, okay? So that's why 27 minus 15, 0 plus 15, okay? So the question is how many $2 ticket does John have? Okay, now it's clear that, so this will be 12, okay? So there are 12, okay? There are 12 $2 tickets, okay? The 12 $2 ticket. And similarly, we can use equations, okay? You not only just learn this method to solve the problem, we wanted to learn how to use equations to solve the problems, okay? Not our purpose is not to solve, just trying to find the answer here. And you have to show the details, and I hope you use the two different ways to solve the problem, okay? Yeah. Okay, so the number of the $2 tickets will be called X. This is the number of $2 tickets, okay? And then the number of the Y is the number of $5 ticket. Okay, so X plus Y is going to be, right, total is 27. And every $2 ticket, the value will be 2X. Every, $5 ticket to be, every ticket is $5. So 5 times Y. The total is 99. Okay. All right. Now you want to find out the number $2 ticket. So in that case, if you want to use a subtraction, you have to multiply by 5. 5Y, you want to get rid of Y first. Okay. 27 times 5. 27 times 5 is going to be 135. Okay? That will be equation 1, that equation 2. Okay? So equation 1 minus equation 2. 5x minus 2x will be 3x. And the 5y minus 5y is gone. Y is gone. And the 135 minus 99 is going to be 36. So from here, x is going to be 36 divided by 3, which is 12. All right? So that's how do we solve it using equations. Okay, you got it? It's not that complicated, right? It's equation. Okay. Right? But you have to clearly write, what is x, what is y here. Okay. So it's very clear what they're talking about. X is a number. Let x denote the number of the $2 ticket. Let y to denote the number of the $5 tickets. Okay. Great. Okay. Now then there'll be a slightly different problem. Still about rabbits and the chicken. Okay. There are 100 chicken and the rabbits. The number of the chicken legs is 80, more than the number of the rabbit's legs. How many chicken are there? Okay. And then you compare which method is better. You still use 2 different methods to solve this problem. But you try that first, okay? You can try and use any methods to solve the problem. Okay. Let's use the first method. Here's the number of chicken. And this will be number of rabbits. This time it's not the number of the legs. The difference of legs. Okay. So the difference, right? So first of all, you assume all the, all the animals are the chicken. So 0 rabbits. Okay, so 0 rabbits. The difference of the legs. Okay, the chicken has more, how many, right? 200 times 2, that's the number of the chicken legs. Minus, right, 0 times 4, that's the number of rabbit's legs. So total is 200. That means in this case, there are 200 more chicken legs than the rabbit legs. Okay, so then you decrease the number of the chicken, increase the number of the rabbit. Now the difference, okay, be careful. Each time, okay, this will be 99, right? You know, you can say 100 minus 1 times 2 minus 1 times 4. Okay, the difference is 200 minus 6. I have to express it in that form. Okay, minus 2 minus 4 will be minus 6. Yeah, one more. Yeah, you decrease the number of chicken again. One more, right? It's a 100 minus 2 times 2. Here's 2 times 4. So actually, this will be 200 and minus 6 times 2, because when you multiply this out, right? Let's see. Yeah, be careful when you do the computation. Yeah, this will be 100 times 2 minus 2 times 2 minus 2 times 4. So combine those two together. That's a common factor here. So it'll be 2 times 6. Okay. So every time it decreased by 6. So you want to get all the way down to 80, right? To 80, because this will be 80. Now, how can you get 80, right? You have to solve kind of equation, okay? You have to solve, you have to solve an equation. 80 is going to be 200 minus 6 times some number, okay? So that number will be 200 minus 80 divided by 6. Right? So that'll be 120 divided by 6, and that'll be 20. So that means 100 minus 20, 0 plus 20, okay? And that will be the result. So they are total 100, they're total 80 chickens there, okay? 20 rabbits. Okay. It's similar, but in the last column, you have to take the difference instead of add them together. So it's a little bit complicated. Now, if you use the equation, the number of chicken and plus the number of rabbit is going to be 100, right? The difference, the number of the chicken, okay, minus the number, 2 times C is the number of the chicken eggs. 4 times I is the number of the rabbit eggs. The difference should be equal to 80, okay? You want to find the number of the chicken. So what you're going to do is you have to get rid of R, right? So what you do is you multiply the first equation by 4. So it's 4C plus 4R equals 400, okay? That'll be my equation 1, that'll be equation 2. Now, how can I get rid of R quickly? Well, equation 1 plus equation 2, not subtraction, okay? So 4 minus 4 is gone. So what you get is a 6C equals 480, okay? Right, 400 plus 80. So that implies C is going to be 480 divided by 6, right? That'll be 80, okay? So much quick, easy. So sometimes you see the power of the equations. Okay, you can compare which best, what is better. I think if once you know how to solve them using equations, y divided by 6, because 4C plus 2C is 6C on the left-hand side. This is the two equations we are adding. I multiply, okay? I multiply the first equation by 4. So when I add them together, R will be gone. So, but this is 4C plus 2C, that'll be 6C. All right, so now this is another problem, very similar. Okay, 50 students get 11 boats of two kinds. 6 people can sit on a large boat, and while 4 people can sit on a small boat. How many large boats are there? Okay, you have to make arrangement. Sometimes you can solve, you can find the exact number. Sometimes have multiple solutions. All right. So very similar, right? As the number of larger boats. Yeah, let's use the number of larger boats. The number of larger boats. Here's the number of small boats. Okay, and here's the number of the people. Okay, let's figure it out. Assuming they are all 11 large boats, 0 small boat, right? Because every large boat, you can have 6 people here, so total 66, right? 11 times 6. But we have a 50 people, 50 students, right? You don't need a, yeah. So if you decrease the number, you increase the number of the small boats, right? Okay, so the difference here will be right? The number will be changed, right? The number will be changed. So 6 to 4. So the net change actually will be 2. Okay, right? You can calculate it directly, 10 times 6. Yeah, so you see, you move, you decrease the number of larger boats, so you feed, right, 6 less, 6 people less, but you also get 4 more people on the large boat, a small boat. So the difference is every time you decrease the number of the large boat, you decrease the number of the people, right? Students, okay, by 2. So then, what number you are going to get in order to get 50, right? So that number must be 8. Okay, so that's why 11 minus 8, 0 plus 8. Okay. See? Yeah. So the answer here is B3. That means there's 3 large boats and 8 small boats. Pretty similar. Okay. Now, if you use the equation, L plus S, L means the number of larger boats, S means the number of small boats, 11. And then for large boats, you can have 6 people. For small boats, you can have 4 people. The total would be 50. Okay. Okay. So get these 2 equations, and you want to find the number of large boat. Okay, right? So you have to get rid of S first. So you multiply the first equation by 4. Here's 44, right? That equation 1, that's equation 2. So equation 2 minus equation 1, why? Because that 6L is larger than 4L. So you got 2L. 4S minus S is going to be 0. 50 minus 44 is going to be, right? It's going to be 6. So clearly L is going to be 3. Okay. Okay, please stop typing the chat window. Mike, don't do that. All right, so let's continue work on the next problem. So it takes 45 hours for a small pump to empty the pool. 36 hours for the large pump to empty the pool. It is known that the larger pump can empty 4 gallons per hour more than the smaller pump. How many gallons of water in the pool? Wow. We don't know how many right, let's draw the picture, right? I have 40 hours. So you needed to know the rate, right? You don't know, yeah, small pool to empty, right? Small pump to empty, right? 45. Yeah, think about this problem, okay? 36 hours for larger pump. All right, let's try to solve it using the equation, maybe. But we don't know how much water in the pool, right? It's called the X. Okay. So X gallons of water total. So we try to compare the rate. So larger pump can be empty 4 gallons per hour more than the smaller pump. Okay, what is the rate of the larger one? Right, the larger one is X divided by 36. That is the rate. This is a number of gallons of water, okay, per hour, okay, can be emptied by the larger pump. Okay, so this is the large pump, the rate. We are talking about the rates. Okay, this is larger pump. Okay, and the small pump is X divided by 45, right? So that is small. Okay, so now the difference, right? The difference is going to be, right, is going to be 4. Okay, so that's it. Okay, so the question is, how can you figure out what is X? Okay, using the equations, you can write down one single equation and you can tell. Okay. All right, to solve this, I hope you already know how to figure out the fractions, okay? If not, then we try to multiply both sides by a larger number to get rid of the fractions, okay? So 45 is going to be 3 times 15, right? And let's try to see that 45 factored. 45, 3 times 5, right? Because, yeah, 36 is a 2 times 3 times 2 times 3. So in order to get rid of all the factors, I needed to multiply both sides. I need a 2 times 2, right? I also need a 3 times 3, right? I also need a 5. Okay, so what number I'm going to use? 4 times 4, right? So we 2 times 2, 4, 4 times 9, and then times 5. So we need 180 to use it. Okay, multiply both sides by 180. 180 times x over 36 minus 180 times so it's 4 times 180. Okay. Oops. Okay. So let's simplify. 180 divided by 36 is just a 5, right? And the 180 divided by 45 is going to be 4. Okay. Then here's the 4 times 180, right? 70, right? So X is going to be 720 gallons of water. Okay, so you solve the problem right away. Okay. Right? So if you use the equation, it names the variable for the unknowns in the question, that'll be super easy then. Now, can you solve the problem slightly in a different way? Well, so you can think about how many gallons of water left in the swimming pool if I use let's see, you have to think about slightly different ways. If without using equations. Okay. So every time, right, the larger pumper can pump 4 gallons more water, 4 gallons per hour more water than the small pumper, right? So if you use a larger pump, if you use a small pump, right? If you use a small pumper, simultaneously, let's do that was exact same pump, same pool here. So here's one, you just do the same way, right? So this would be the larger pump here. That would be the small pump here, okay? So let them to start at the same time, okay? At the same time, okay? Then you will see this side is it's empty, right? 36 hours later, okay? In 36 hours, this side is already dead, empty. In 36 hours, right? Right? Now, how many times left for the small pump? Well, 45 minus in 36, right? 40 for the small pump, it takes additional 9 hours, right? 9 hours, right? So additional, there's some left here. Okay. So this is 40. We don't know how much left. So in additional, it takes 9 hours. 9 is going to be 45 minus 36. Okay. So 9 hours to empty how many gallons of water? Okay. How many more gallons, right? Because 36, see how much water left for on the other side? Because The larger pump every 1 hour, right, empty 2 more gallons of water. So 36 hours, the larger pump, right, pull out, right, pumps out 4 times. 36 is 144 gallons water. So if we can figure it out, 144 gallons of water, okay, left in the other pool, okay, which we are using the smaller pump, okay. That's why then you figured out how fast it is of the rate for the small pump. The rate for the small pump is going to be 144 over 9, which is 16. So 144 over 9 is 16 gallons of water. You see, without using equation, it's pretty complicated per hour. Okay, that's a small pump. Okay, then amount of water in the pool will be amount of water in the pool will be 16 times that is the rate times 44 hours. The amount of water in the pool will be 16 the rate and 45 hours, so 720 gallons. Okay, so it's let me repeat again. Okay, you have 2 identical pools, left and right. On the left hand side, use a larger pump. On the right side, use a small pump. You let them to start pump the water out. Okay, then at the moment when then the pool on the left side empty. Okay, that was 36 hours. Okay, and how much water left in the pool on the right hand side? That's a question. Yeah, if we can figure it out, that would be 4 times 36. Why? Because additional water each time, right? The larger pump empties, right? It's going to be 4 gallons per hour. So you just put 4 gallons per hour. So 4 times 36, that will be what is that how much water is left in the pool on the right hand side. If you can figure out that, then you're done, because then you can use that number and you take additional 9 hours. So that's why you can figure out the rate for the small pump. And then you solve the problem, then you 45 times the rates that get total amount of water. Okay, but see, you without using equations, okay, you still can solve it, but you have to be much smart, okay, to do the comparison. Okay, then the one uses equations straightforward actually. Okay, then you write down the difference, then you solve for x. Of course, a little bit technical here. You have how to solve x. If you shouldn't know how to add the fractions or do the subtraction for fractions. Okay. All right, let's take a look at the next problem. Let's take a look at the next problem. It takes 50 trips for a larger trunk to transfer the sands from A to B, and 80 trips for a small trunk to complete the job. If the larger trunk can carry 3 times more than the small trunk, how many tons of sands are there? It's very similar to the swimming pool problem, right? The previous problem. Okay. This time I just use the equations. Okay, we don't know how much sands here, right? So this is a sand. Okay, let's call the S. Okay, S tons. Okay, right? So we know the rate. Okay, how many tons of sand? Right? How many tons of sand the larger trunk can carry? Right? So the rate, we compare their rates. Okay, So this will be the larger one, that will be the small one, okay? The larger one will be S divided by 50, right? The small one will be S divided by 80, right? So the difference should be equal to 3, okay? So if you solve the problem like that, then you can quickly get, okay? Okay. All right, let's combine them, okay? So multiply by, now you can solve this equation, just add the 1 over 50 or minus 1 over 80. But you can also multiply by 400, for example, okay? Multiply by 400 each term, okay? Then you will get, right, 8s, 400, here's a 5s. And the 3 times 400 is going to be 1,200. Okay. Then the 8, 400 divided by 80 is a 5, right? So that'll be 3s equals 1,200. S is going to be right? It's 400, right? That would be the easiest way, in my opinion, if you know how to set up equation. Okay, you try a different way. Okay, just like what I did as a second part for the previous problem. Okay, you have to let the larger chunk to carry all the thing. You make two sets of sands parallel, right? Left and the right, and let the larger trunk to carry the sands of the left, right? And then you see that's when it's finished, then you still have some sands left, right? So you can for the small trunk it takes additional 30 trips, okay, something like that. So you can figure out the rate for the smaller trunk. Then once you figure out the rate, then 80 times the rate, you get the total number, amount of the things. So I'm not going to go through this again, but you can try it, okay? All right, let's take a look at the next problem. All right, this problem we can use, it's very similar to the chicken leg problems. Okay, let's go back this. All right, and you can use 2 different ways to solve the problem. John transports 1,000 glass cups. John can earn $1 for each cup and lost $3 for breaking a cup. If John receives $920, how many cups are broken? Okay. Okay, how do you, let's solve the problem without using variables. Okay. So here, good cups, here, broken cups, right? and then the money he can earn. Okay. Now, suppose all of them are good. 1,000, right? He can earn $1,000 and zero broken. So he can earn $1,000. Okay. But that's more than what he got. So every time let's decrease the number. We assume that there's a one broken. And this time the net change will be what? Will be the net change will be $4. You know why? Because he make one less, right? $1 less, but at the same time you have to pay the penalty, right? $3. So total will be $4 total. You lost $4. Right? Yeah, -1 -3. That's why it's $4. Okay. So eventually, and $1,000 minus $4 times some number. Okay, this is a number, right? And then that will be 920. So, what is that number, right? That number will be 80 divided by 4. So that number will be 20. Okay. Okay. So that means 20 cups are broken. Okay. So it's 1,000 minus 20, 0 plus 20. Okay. So the answer is that 20 cups are broken. Okay. All right. Now, using equations, you can let G denote the number of good cups, B are the broken ones. Total 1,000 cups, right? The money you eventually can earn is for every good cups, you can earn $1. For every broken cups, you have to subtract 3 times the numbers of broken cups. So total, you earn the 920. Okay. So you want to find out how many of them are broken. How many of them are broken means you have to get rid of the G, right? So all you have to do is just use a subtraction. Okay. So equation 1 minus equation 2. So you get G is gone, right? B minus -3B actually is the addition. It's a 4B. Yeah, that's the trick. Then divide by 1,000 minus 920, that will be 80. Okay, so that implies B is going to be 20. Okay. Yeah, be careful. B minus negative B, it's going to be 4B. Okay, negative becomes positive. Okay. You can also get rid of B first by adding together. Have to multiply the first equation by 3. Then add them together, you find the good cups. Then you can figure out the broken cups. Okay. All right, let's try the next one. Now, we hope we can solve it using equations. There are 20 problems on the test. David got 5 points for each correct ones, and then lost 1 point for each wrong one. If John gets 64 points, how many answers are correct? How many answers are correct? Okay. So let's see, let's use the equation, okay? Trying to use the equation first. Let's see, the number of the correct ones. C is the number of correct ones. Okay, and the W is going to be the number of wrong answers. Okay, so how many problems there? Total 20. So C plus W is 20, right? Then let's calculate the total points you can get. For every correct one, it's a 5 times C. Okay, it's the number of the correct problems times 5 because you get everyone, you know, right? Every correct one you get 5 points. But you're also going to lose 1 point with each wrong one, so it's minus W, and that total is 64. Okay. Then, right? In order to get to C, you know, the easiest way to do is just add those two equations together. Okay, that was easiest, right? So it's going to be add them equation, add them together, it'll be 6C. And then here's 84, okay? So C is 84 divided by 6 is going to be 14, okay? And the wrong one is W is going to be, you know, if it's 20 minus 14, 6. So 6 are wrong problems, okay? Without using equations, it will be a little bit challenge, okay? But you have to use a chart, okay? And the correct way, you're assuming all of them correct, then you decrease one by one, okay? Then you still can figure out the number of the correct ones. Suppose 20 problems are all correct, right? You have you're going to get 80 points. No, you're going to get the 100 points, okay? Yeah, 20 times 5 is 100, right? But then, yeah, without using, I don't have a time yet, I just finished this. So this is yeah, correct, wrong one, and then the points you're going to receive, right? If they're all 20 correct, you'll receive 100 points. Then if you decrease by 1 and increase by 1, so the net change will be how many, right? You're going to lose if you lose 5 points, right? Then you lose 1 more point because for every problem make it wrong, right? You actually lose 6 points. So that would be, yeah, we don't have a time now. Yeah, that would be 100 minus 6 times 1, right? And then eventually you get 64, right? 100 minus 6 times some number equals 64, right? So you figured out that number, okay? That number is 100 minus 64 and divided by 6, so it should be 6, okay? So 20 minus 6, here 0 plus 6, that will be the answer. Okay, 20 minus 6 is going to be, you know, is going to be 14. Okay, so there are 14 correct ones. All right, so let's stop here. I did not finish all the problems. I have one more problem to discuss. It's a little bit slow today. Okay. But when you do the homework, I hope you can try 2 different ways without using equations and using equations. Okay.